All right. Excellent. So welcome to the stream. My name is David and I am the developer of Power Network Tycoon. This is a city builder game which focuses on the power engineering aspects of city building and tries to bring some of those aspects into, I guess, industrial level realism. So I'm using IEEE methods of simulating the thermals of conductors as well as generators, transformers, electromagnetic fields as well. I work as a full-time power engineer, so that's my area of expertise. So today we're hoping to play a bit of the game as well as talk a bit about some of the features and some of the underhood calculations and I guess aspects of it that make it unique. I'm dealing with two windows at the moment, so bear with me if I'm looking at the chat below, but hopefully that's coming through. It does look like it. Excellent. All right, so the game uses procedural generation. There's a few biomes you can choose from, and the first one, which is the one which is part of the demo, is this forest looking one. You can modify different aspects of the game, make the map different shapes, have more trees, less trees, or rocks, or whatever suits your playstyle. We might just leave it pretty standard. I think that looks good. All right. And generally you'll be playing with missions or without missions. Missions sort of make the game a bit more fun, a bit more objectives to what you're doing. So we'll play with that. All right, and here we are. It's already started raining. A beautiful day. So you can see at the bottom we have the assets you can place down, bottom left. The actions you can do, upgrade or destroy different assets. Services such as you can give out notifications. We'll go through these in details. Research, the mission that pops up as you go. Manage your finances, and different tools to help you throughout the game. I have unlocked all the tools as well. When you first play, you'll be the power study and the IR tool will be locked, but that's pretty quickly unlocked. So we start with a generator. Generator is something you can see can disturb people if it is next to them, which most games have. Does produce noise, and you then connect your generator to, say, a pole, and then substation, like so. And you connect them as so, and now you've got a load you can connect. There's a little house, and essentially what this is representing here is that we're a electrical utility, and a new island community is growing here, and they send you application requests to connect. So what makes this game a little bit different is we are focusing a lot more on the detail on the power assets. So you are dealing with things you don't normally deal with if you're playing, I guess, simpler games where you then manage other things like fire, ambulance, those sorts of aspects. We don't bother with that. It's purely just managing the power and the details around that. So you can see here's a shelter, single phase, loads are single phase or three phase, depending on sort of how large they are, how much demand it has, and you can choose a phase to connect to. In the bottom right is your generator, and this is the generator where all your power comes from for your island. And we'll go into a bit of the details of this, but you can just choose a phase to connect to. Any household on the street has three phases, and they're allocated accordingly. So in reality, if you are a utility in your local suburb, you do have to consider how you're distributing loads between phases. You want to make sure that's balanced. And generally, you do it sections at a time. You can see that as new loads get connected, I'll just slow it down. We do have new growth, new roads expanding, knocking down trees and such. There is a shortcut as well to repeat the previous action you did for connecting to sort of make things a bit quicker. So I'll just speed things back up to normal. If you hold control, you can just zoom through the connection process. And you'll see on the bottom right, it's connecting to the A phase. Now we'll go into this one here. You can see that it has a particular power factor, and a power factor looks at essentially the loads you're connecting. If you're connecting a factory, in reality, factories have a lot of motors in them. Motors are inductive. Inductive consumes reactive power. This is all, I guess, fairly technical, which is quite interesting for electricians and electrical engineers, and it's important to know. But in reality, if you're playing this game, you sort of need to just look at the basics. You can see on the bottom right, the gauge is at 1 when it's up vertical, and then it scales more or less than 1, lagging to the left, leading to the right. And you need to find a balance between these. And I'll show you what that means. So if you go to another one, it's lagging. Most loads are lagging. Lagging comes from motors and that sort of thing, as I said. You can see occasionally there's leading loads. Now leading is something that is beneficial for Power Network because most things are lagging. But within the game as well, because most are lagging, you have to find alternative ways to add leading or add reactive power to your network. And that's capacitor banks. I'll get into that a bit later. But for now, you just want to essentially balance it. Now, a good thing to do, and you'll find this out, I guess the more times you play it, is to do some research. In the game, you have money. You can see in the bottom, top left, sorry. You have money and you have science points. Science points are required for research, and they aren't in the, or they're earned through missions, but they aren't in the free play where you don't have missions. What I prefer to do is the generator first. It is quite expensive to upgrade, but it is generally the thing that gets overloaded first. So it's $1,000 plus 1 science point. And you can see a bit of the characteristics of what the difference is between the rank 1 and the rank 2 generator and why we would want to upgrade that. One of the important things here is the maximum number of connections. So at the very start of the game and in the demo, we're using only simple poles, the simple generator as well. And it limits how much of a mesh network you can make or how many loops you can make. So you're essentially making a long linear string. And what that means is you overload some of those first conductors. So we'll choose the power generator to upgrade first. Keep connecting some of these loads. Power factor. All right, so we've got our first mission, and there you go. This one I made in part to be a tutorial to sort of tell you, hey, capacitors or capacitor banks exist, but also provide some early, I guess, rewards. Gives you a bit of cash injection once you complete it. So this is saying, hey, your power factor on your network isn't quite at 1, at unity. So a capacitor bank can help. So we'll go to, actually I started, you can only research one thing at a time. So we started this one. A few seconds later, we can add a new one. There's also game speed. It's probably worth going through that. Game speed's good. If something's going really bad, you can slow it down. You can start doing some modifications, rediverting conductors that may have failed, or if you need to get rid of a pole, but you don't want everyone to lose power for a long time, you can slow down. I didn't want to have pause in the game. I think that sort of removes a lot of the element and the challenges of reality of running a utility. You can't just pause time. But yeah, normal speed is usually pretty good for most gameplay. Fast is good if you've connected all your things. You want to maybe get a bit more money as you connect. See that? Zoom in, shows you the money. Or research completes. So we've just completed our upgrade for our power generator, and we'll do the capacitor bank now, which is part of that mission. You can see here in the missions tab. There's sort of the detailed mission pop-up that came up, and then the summary, which is just research capacitor bank. Some missions are timed, some are not. Often the timed ones are when there's something like the regulator, electricity regulator, comes to visit your island. Each island has a little dock, and you can see that there's ships coming in and out, essentially as the island's growing, dropping off resources to help the island grow, add a bit of realism to that. Here's the researched capacitor bank actually coming through, which is good. So once we reach about 0 seconds on the research, that'll land, and then we'll have access to this capacitor bank off the back of this ship, which will be good. Ooh, that's bad. So I guess one of the realities of managing a power network is that you need to deal with the weather, and it's being unpredictable in ways. And so storms do come through. I'm fairly early in the game. I haven't researched in support systems, so we're about to get capacitor bank. I haven't researched lightning rods. Lightning rods are good for protecting your substations and your generator. They can absorb that lightning to save the asset itself, but not necessarily the people around it. It's a different process we'll go through. But anyway, we'll see how that goes. The capacitor bank's coming through. We'll get back to our town. And a capacitor bank. Oh, there's the lightning. Thanks for choosing me. Now, this is going to not be good. You can see a voltage value come up. We'll go into that later. They're happy that I completed the capacitor bank research quest, but killed some people at the same time. That's fine. So we've got some money, we've got some science points, and you can see the exclamation mark here. This is sort of the only time you get a pause in the game when there is a pop-up or you bring a menu, but you can't interact with things. So generally the X in the bottom right here means out of the range of your substation, and exclamation mark means there's an issue somewhere. The issue is on this conductor that got struck by lightning. You can see there's still a lightning storm active, but we'll see how we go with this. I can repair it pretty cheap, being first rank, and that's good. Now let's just wait a bit, because I knew something else would get struck. Oh, the same one. Struck the same location twice, which is equally likely, or more likely. Ionized air. So the storm's ongoing. I believe that there's 3 strikes is about the most you get per storm. So sometimes you get a particularly bad power factor load. In reality, if you're a factory, if you're owning your own business and you talk to the utility and you want to connect a really bad power factor load because you've got lots of equipment that does consume reactive power, they will tell you to install a capacitor bank. And I guess this game sort of introduces some of these complicated concepts that have their roots in reality. These are shunt connected or connected in parallel with your load. I'll just show you what I mean by that. So a capacitor bank in this game has a particular range with it, and you can see as you're choosing where to place it, it's going to help a certain amount of lagging loads which are connected to this substation. So here might be a really good spot for, can reach those 4 loads. We'll put that down and we'll say capacitor bank. This section here actually I elaborated on to provide information as I got queries about capacitor banks. So there's 5 loads nearby connected to the substation, and there's 4 that are needing a capacitor bank because they are lagging. So if we connect that up and then you click on this load, for example, you'll see that it was lagging and now it's been corrected to being leading, and that should start to balance our network. We might have to install another one, maybe over here. And you can see on the right, there we go, it's starting to look a bit nicer. Now you can see there's a few houses that have expanded a bit further than our network has, but we should be able to expand our network to join them. Alright, so the lightning storm's still going, but I'm feeling confident we won't run into any issues there. Alright, we'll just connect them up to B phase, just out of range of that one. New mission. We'd like some extra poles to support the timber industry. I can do that. Now, poles are good in the long term, you'll notice, because they allow you to connect. Okay, storm's past, happy days. They allow you to connect multiple conductors, whereas the substations, the way it's been built in the game, has an input and output. It's got two connections. But if you want to get a nice big mesh going or rings, it is useful to have poles. So we are expanding along a bit. I am hesitant. I'm hesitant of overloading this. We did kill a few people, which was good for our loading. It's probably not the right way to do it. But we can monitor each asset as we go through this, and you can also tag it here to stop it moving. So, for example, conductors, you can watch the temperature. It's quite a cold day, 8 degrees. So the conductors are only 13 degrees on each phase at the moment, and you can look at the detail of what's happening in terms of that heat. So these are the elements of the game that I guess make it stand out, but there's some of the overlooked elements perhaps, or under the hood elements that I tried to bring out a little bit in here for the interest of anyone that wants to know how much is due to the sun coming down on the conductors, how much is due to the amps flowing through the conductors. There's wind coming through in the top right. You can see the wind, its direction. The conductors have a particular direction as well, and that affects how much cooling occurs. And the modeling of these conductors here, even though they do look very basic, that's based off IEEE 738, which is essentially the industry standard for any modeling software for a power utility. So if any utility comes along and they're going to model a new suburb and put in some conductors and determine what kind of conductors they're going to use based off how they're going to be installed and what sort of loads they're going to have in the substations, they'll be using IEEE 738 most certainly. So we'll be putting that load on B phase. Don't put that up. And you can see our substations here. We're at 220 out of 500 kVA. And that's not too bad. I'm sort of stalling a little bit because I'm pretty poor. I didn't expect to lose so much money to start. Actually, I've got to, what am I doing? You can also make good money doing missions. As I said, some aren't timed. Some are just sort of waiting for you to do the mission. So they wanted, how many extra ones? One more. That's pretty easy to do. And then you get some money, 5,000. So we're just under 10,000 to upgrade that power generator. It shouldn't be a problem. I'm going to, it's not raining today. I'm going to connect up this. And we met our GDP, which is sort of the wealth of the island milestone. So essentially what you're here for on this island is to help it grow. And so part of that, of course, in modern society is having power. That's the role you play. And so that's the target for you. The target is 100 million to complete the island. Although you can play beyond that. And that's good. The regulator has rewarded us with a grant, 5 grand for that. They're happy, we're happy, and there's our new power generator. Excellent. Now, a bit more detail. The flashing, that is penalties, and people get upset when we're taking too long to connect their load without a good reason. We can reject them. That's once again something that can upset the regulator if you keep rejecting loads, because we are here to help the community grow. But that's not what we want to do here. Now, a reality of running a utility is to have the ability to maintain a stable supply. And part of that in certain countries, particularly important, is load shedding. Now, load shedding, as this says, it's a strategy of preventing the system overloading by intentionally disconnecting large industrial loads when demand exceeds supply. Players can manage load shedding by nominating loads to disconnect when required, but will need to compensate the customer when this occurs. Now, this is an interesting one. So I was talking to someone from South Africa about this, and there's no compensation for disconnecting when needed. In where I am in Australia, we have certain systems for this, and certain industrial loads can nominate themselves to be disconnected, and they get compensated for that. So this is what the game has built into it, and it gives it a better mechanic essentially. So if you have this load connected and you've clicked load shed, before the substation overloads, it'll disconnect the ones you've nominated as load shedding, but it doesn't do residential loads, only commercial loads, which are deemed as less important. So you can do that on anyone. If you hold control, of course, repeating the same action, it'll also do the previous settings, so the phase you had connected and the load shedding, whether selected or not. Sometimes in reality, you probably want to start rejecting some of these low power factor loads. We actually have quite a nice power factor at the moment, so it's nice to maintain that. And when they're rejected, they'll sit like this, getting very upset because they needed power, but they should have built their load better. Look at that, spot on one. This guy gets the gold star. So as we're expanding our network, we have upgraded our power generator, and we no longer need to really have this linear load here. We can sort of zoom out and maybe consider a different path. At the moment, it doesn't really matter about trees being in the way. I'm not sure what to do about that. It might be just too annoying if you run into a tree with a conductor, so I've left it as being quite relaxed. Here's a mission, which is another reality of life as a utility. You have upset people in the community that don't want electrical assets in their neighborhood. So a VIP from the community has complained to the regulator that there is a pole close to their property, small house number 17. The regulator has asked you to resolve the matter. It's not necessarily that it's illegal. They've just asked to fix the problem. They will arrive at the dock, and we saw the dock before, in 3 minutes. This is a timed mission. If you have a large network, it can be really hard to move assets because you're space constrained, which is another reality of running an electrical network. But also, it's just it's disrupting power. Like if you're disconnecting a pole, then you've just lost the cables between it. So I don't see a need for that pole to be there. I can put it a bit over here and annoy this person. We might just do that. I don't even need to really slow down time. There's not too many people around. And now we've done that. So I anticipate that should be far enough from load 17 to keep them happy. And then when the regulator comes in 2.5 minutes, he'll be happy. It's not the regulator. Okay, so yeah, what are we doing? So we were getting a ring, which is nice. I'm just sort of giving myself some space here. It's a bit overkill, but it's kind of nice. I might also start some research. Maybe a conductor. All right, so let's get this going. Did I make a straight line? Oh, I didn't. Oh, I was drinking too much water. Okay, so now this is where I have not seen pretty much any game do this well, because it's complicated. There's maths. So you'll see here's a conductor providing power into this substation from this generator. And it is providing this many amps along this path. And these conductors, which are connected to the same generator, should have none. Amps at the top, current. Now, when you connect another path, the power can flow either way. But how much flows between one way and the other way is something that games tend to never really put any effort into. They might split it. They might just not tell you where the power's flowing. Like Satisfactory, for example, when you're connecting up things, it doesn't really tell you the detail. As much as the game is incredible, it's not reality simulator. But when we connect this up, you'll see, so that's energized now. Beautiful. And you've got a certain amount of current going through here, pumping up that temperature as we go. And then you've got other current here. So 18 going to here, 20 going to here, and 20 slightly more because there's slightly less path, and each conductor has a certain amount of resistance. And so this is the lower resistance path, essentially. There's also, I guess, the detail, which really is overkill for the average game, which is that you've got temperature here, but resistance for this lower resistance path is dependent on temperature. So as it carries more current, it gets hotter. And as it gets hotter, it gets higher resistance. Now you see here, these just load shed. So these disconnect. So that's a bad thing. So if I look at this, yeah, 580. So this started getting a bit shaky. I've been a bit distracted. But yeah, anyway, there's a lot of detail here you could easily overlook, which allows for a lot of interesting options now that the system's built. What do I do? So I can't yet, I haven't upgraded these poles. I can't split off a new conductor here to give myself a new substation. I might actually just get rid of this, give myself a new substation here. Now when connecting these loads, I'll start putting something on other phases. That should be a bit more evenly distributed. No, they've reconnected on there. How much went on here? 200. Yeah, okay. We still need probably some bigger substations. Those loads are probably going to disconnect, or some of them, the ones that ended up back on that substation. So that's conductor upgraded. Now we've got one science point. I do want to add more complicated networks, so I will go for a pole upgrade. You can see here as well, once you've got an upgrade done, you can choose to just by default install those higher rank conductors. Also, I guess the number keys allow you to move between those on a keyboard. Now we're doing this. So alright, so we've been going pretty slow, so this quest is still going. That's that pole here. Two of the exact same house. Very confusing. And that's good. So this is as far as the demo goes in terms of upgrades, or maybe we've gone a little bit further. So you've got this one upgrade that allows you to at least get a ring. And rings are nice for, like I was saying, splitting the load between different currents and different paths, which allows you to not overload these first conductors coming off. They are getting a little bit hot. Maximum temperature is 100 degrees Celsius. So it is good that we've now upgraded some, and we can go bam, bam, and then instead of 5mm square, we're up to 22mm square, which is sort of the next jump up. And then they should sort of cool down a bit now that they've got a bit more copper in the air to not overload. This is a low power factor. I might just reject that, start doing the right thing for my network. A bit more cool. Now, it's worth probably talking about some of the ways we can influence the customer on our island. So we have these community notice we can send out as a utility. And I'll go through what each one does and sort of when you use it. So first one, disruption notice. So disruption notice is good if you, for example, had a lightning storm, took out part of your network or something overloaded, and you've just lost a lot of customers. It can also be good if you started building into a new area. You can see at the back here, there's new unconnected loads. If you can't connect them very quickly, for example, if you were overloading your substation, it can be good to give a disruption notice. In reality, usually if you've told the customer, hey, we can't connect because of these reasons, it's unlikely that the regulator will get upset with you. You can justify your reasons for doing that. Now, improved power quality. This is something which is fairly cheap and can essentially it means that you're telling the customer, you know, here's what you should do when you're building your factory. Just produce a higher power factor or higher quality product. So that means you'll get less of these low power factor loads coming along, and it can be quite good for long term. It's pretty cheap, lasts 30 seconds, which is good. Now, emergency alert. This one is so it warns the community how to remain safe during electrical faults. Such equipment failures or such as no, okay, got out a word there. So essentially, if you're in a lightning storm at your house, you shouldn't be having a shower or doing the dishes in the sink for various reasons, but you don't want to be touching anything metallic. So that warning that gets sent out reduces the probability during a potential rise or a fault event of something dangerous happening. So less likely to kill someone, which keeps people happy. Energy efficiency, so trigger this and people start being a bit more energy efficient. It can be good if you've got a substation about to be overloaded. And this last one, this is sort of the most expensive one because it uses one of your science points. So unlikely you want to really do it, but it's a technical clarification where the horrible thing you might have done where you didn't upgrade your network and you've just killed the entire neighborhood due to your explosion, your substation, you can provide a clarification as to why something happened or why you've upset all these people by rejecting their applications, and get rid of any bad press. Now, what I mean by bad press is your community satisfaction. You can see at the top, it's at 83% at the moment, and that's not a bad number, but customers get upset if you reject their applications. Also, if you kill someone, they remember that for a little while and get upset. And a lower satisfaction means there's less activity happening on the island, and it doesn't expand as quickly. We'll just go back to normal speed, gameplay, get this research at the pole done, and I reckon we can upgrade one of these and expand out this way. Now, you can also make a bit more money if you want. So, as a customer, you pay a tariff for electricity at your house, which is essentially a sum of the electrical utility, which is you playing this game, their costs for maintaining their network, building their network, and paying for electricity. You can vary this. If you make it too high, you'll see that people get a little bit upset and they get a bit sad. You can start giving them free electricity and pump this up, and everyone's happy with not paying for electricity. But it's a good middle ground there. Maybe we can even increase it a little bit. You'll see also, there's a generator. You can see here we are paying $177 essentially for the fuel to power this generator with these electricity production costs of 10 cents a kilowatt hour. And you can also look at penalties in this location, which is usually where you haven't connected some load in time, like that one. Beautiful. We'll start connecting those. That's good. Connect up to A phase. I might also just show you that one. So if you do that one, lasts for 30 seconds. It's got a cooldown for 30 seconds as well. But yeah, while it's active, if any loads come along like this one, improved power quality, it's all pop up there. You'll see it's going to have quite a good power factor. And this load, because it might be here for quite a few minutes, it's worth having that. Put this on the C phase. Substation's at 56% loading, which is probably this one. Yeah. Research pulse. Okay, so now this is good. We have, I'll leave that normal. We have, oh, that's heavily loaded. That's probably this one. Yeah. We'll upgrade this, and now we can go this way. And, I think I just passed that mission. pressed escape at the exact same time it came up, but that's fine. We passed that mission, probably got $5,000, it's good. Doing good for cash. And we have had some load shedding from this one. That's good. So now we've built a tee off, essentially. A little bit messy to try and get past that road, but that's good. We can now expand into here. I've started to like poles. I'm going to even just start putting higher rank poles. You do find that you wish you had a pole between, say, two substations because you can't tee off. It's good to have the option. All right, now that's good. We have met a new goal. So that's our GDP, gross domestic product. How much the island's wealth is, essentially. That's good. New milestone reached. Okay, new mission. So they want to inspect our progress on the island. They want us to have a satisfaction level of 74. You can see at the top, I've been smashing it, connecting these new loads. Hopefully I'm not giving them free electricity. I think I changed that. And have one more poll. I'm definitely going to put a poll within the next 3 minutes. That's good. I was just thinking that some of these early areas in here are probably quite heavily loaded. I can upgrade these substations if I bothered to, well, I guess I just got my science point then. Yeah, I should have probably done that a little bit earlier. That's fine. Now we'll upgrade this one. Upgrade and tee it off. Okay, now we've got a different option for what we connect. I'm going to keep load shedding options where I can. It gives me some good options for what to do. Okay, we have getting a few extra things on here. We have progress. Now, one thing I haven't even touched on, which it is quite important, and it's one of the elements of the game. Once again, I'm just going to pause. That no game that I found has really touches on it, and that's another IEEE standard, and it's extremely critical for every house. It's to have earthing. So earthing's complicated, or grounding if you're in the US. It's a complicated topic, quite expensive. I should probably have enough money for it. And so I've developed a tool here, and this tool is very similar to a tool that if you're an earthing expert, like a power engineer that specializes in earthing or grounding, you would be looking at. So what happens, and this is an overlay of the town or the electrical network I've built. You can see the ocean out here. And what it shows is the voltage that occurs if a fault occurs on the load that I've selected, whatever it may be, whether that's the pole or the generator or the substation. You can see that's the representation of this string here. And what you do to manage this in your house is to put in a rod, maybe like a 5-meter rod or something. Depends on your council or your district or whatever the term may be. But it gets a bit harder when you aren't just a household, where you are a big substation and you have higher voltages to manage. And so what we need to do is look at ways, you can see here on the left, which is the power generator. Look at ways to manage this. So here we have five electrodes going in the ground. Essentially, that means if you get lightning, that lightning will go from the substation or the generator into those into those electrodes and through the ground and dissipate out. Now that can be good because you want it to leave your asset, but it can also be bad. So you can see here, if that does occur, if there's a fault on this generator, any neighboring buildings will have a voltage of about 3,000 volts, and that's quite a lot. So that means if someone's walking or touching something, they'll get about 3,000 volts between, say, two things you can reach with your arms, or your between two legs if you're sort of stepping at that distance. And so you want it sort of lower voltage levels of about 400 or less. And the way to do this is to reduce your grid resistance, the total resistance, which means adding more copper in the ground. Like you put copper in the air to reduce resistance in the aerial lines, you just want to put more in the ground. So I'm estimating that you maybe 10 meter rod, 5 of those, spread them out as much as you can, save that as my favorite one. And I'll do a calculation to see if that looks good. And it looks like it's reduced this one, but I've got all these other ones. Now I've completely neglected this here, which means I have to fix up quite a few, but that's fine. It does cost a little bit of money, 720. We can go through some of these. Load, just keep doing that favorite. And you can see it's reducing that sort of dangerous ring of voltages around our electrical asset, and reducing our earth potential rise. It is still present. I might bump it up, save that as my favorite. Probably should have maybe, yeah, that's all right. It's still pretty good. Massive improvement from these 3,000 volts or so. We're looking at still about 500, 600. So if they're right next to, if there's a house right next to our substation, when it fails, we will get some issues, but it's not looking too bad here. Load. And how much is this costing? I had about 20,000 and I've got about 20 assets to upgrade. About 1,000 each, but this will be good. So this will stop deaths occurring, which is good for maintaining the network with the island growth rate, but it is not good for my bank account. Ooh, it looks like we can actually afford to do all these. This is good. Beautiful. Okay, so you can sort of see the road now underneath. Or you can do this if you don't want to see anything complicated. So that's good. That's not too bad. We'll save and close. Ooh, I think that's saying I ran out of money. Yes, I did run out of money. That's fine. We've done the final modification. And if you click on a pole, for example, you can see there's not much details of a pole in this game. Electrode 10 meters, so that's good. Or if you're looking at something more complicated, electrode 10 meters, we can see we've got some nice 10 meter electrodes on each of our assets, rather than the standard 2 meter that each one gets installed with. Now, we've been going on slow, which is all right. I can easily pass this one. I just need to expand a little bit. Right. Upgrade that. Now, I reckon we can, I'm going to do something a little bit tricky. Well, this might just be annoying for being too close. I'll upgrade that. I'm getting a lot of penalty, actually. Two. Beautiful. Okay. And we'll connect that up to here. Did I research this? I did. Okay, excellent. So, that's good. Now, you have a large network now of assets, and you might be wondering which ones have I upgraded and which ones have I not upgraded. And a good way to do that is to essentially do a power study. And a power study is what a utility would do to look at the whole network, look at weak points, and look at where upgrades are needed. This is essentially, you can't click on anything in here and it'll take you to its location. This is every asset I've built, except for poles. So we have conductors, we have our substations, one's looking a bit dodgy, and our power generator. So you can see one of them here is looking a bit overloaded. It is a fairly cold day, so it's not quite meeting its rated temperature, but we can upgrade those assets in here. We can also click on it, you can look at it where it is, and it's one of the early ones. I sort of suspected. I suspected it would be one of those ones that was needing an upgrade. So we go upgrade, which is the new rank we've just researched, and now the rated power is 1.5 MVA, so we've upgraded that a little bit. Red means I'm too poor, so maybe I should have upgraded the other one. But we're here. Need 4,000 for the next upgrade. That's fine. I'm going to get some money when this mission finishes. Hopefully it doesn't overload. That's that one. I can also, you can look at some assets and you can say, hey, ooh, yeah, that's a big building. That's good. That's next to my brand new substation. You can also go to one of these loads that you connected and say disconnect, and then reconnect it to a new substation. So this brand new one that I built just here, you can see the substation I found. It likes to find the ones that it's the most logical to connect to. You wouldn't connect it to one at 108% or 43, you'd connect it to the one with the least. So we can connect that there. And we can connect these up for some load shedding. I have the money now. I'm going to upgrade this one. Now, that's looking quite good. I'll just speed things up. I'm playing quite conservatively, which is probably good for making sure I can show parts of the game that are probably where, show all aspects, but one of the aspects I won't necessarily get to by playing conservatively is what happens when things go wrong, which I think is important to at least experience a little bit. These nice big houses. So we're gonna get some extra money soon, which is nice. I'm gonna speed things up a little bit, and I can't afford any research. That's a shame. And part of the reason for that is to show what happens with some overloading of assets. We are going pretty well managing the distribution of houses on our island. It's all gone to one side, it looks like. It's its favourite side. Got quite a few things coming in at the dock. And we have quite a few loads that can be load shared. I'll just show that now. So we finished that quest, it's good. We met the customer satisfaction. Completely forgot to track that, but we've been doing good. And we've got enough poles, just by one. That's good. Now when it comes to the substations, you can look at that substation. You can also put your mouse over it, and as you can see here, put mouse over here. It links the ring and also what's connected, but you can look at it in detail as well. So on your particular substation, you have a bunch of houses you've connected, a bunch of them that you've selected, hey, load shed this when required, and you're going to have to pay some money. Some of them, I guess I didn't select load shedding. You can update that, say, yep, I'm going to load shed that. You can see that if this was a heavily loaded substation, this is an upgraded one. After load shedding, when something goes wrong, we'll be down to just 7% loading, which is good compared to before load shedding. We can also just manually disconnect some substations, some loads if we want from this substation, which is good. So I thought I'd just show that. So if you're wondering, did we connect any really bad loads, low power factor, you can look at it here, which is good. You can also, this is an area I want to work a bit more on as I go through early access, which is coming up soon. I can modify the protection system within this substation. So for example, at this substation going sort of the in and the out, or the two feeds coming into it, you can look at the current carrying capacity of the wires coming in, and you can, if you want, calculate how much you want the setting to trip at, which is an overcurrent setting, or you can just tell it, hey, calculate for me. And what this will do is it'll trip the substation before it overloads. So instead of repairing it because you pay a lot of money to do that, you can just do this tripping and just closing the circuit breaker afterwards. Save you some money, but it is also an event or you lose power to those loads. So you can still lose money through penalties unless you do these disruption notice or something, or just reconnect them quickly. So you can see some larger loads are coming through now. The community's growing, which is a good thing. We have ever growing demand. Ooh, load shedding over here. This isn't good. Just dropped its load, literally. I wonder, you can just reconnect them as well, like using a shortcut. And by default, load shedding is re-enabled still with those ones. But if you do that, you'll see that it'll eventually overload it. They're disconnected for a reason. Now you can see these voltages coming up here on each load. They're essentially, as we saw before, so you can compare this, they're essentially these voltages. These are the new assets I just put in recently that I haven't done the earth before. These are the voltages that you'll experience during the fault. We saw that, and they were quite safe, or on the border of safe. And this is based off IEEE 80, which is another sort of industry standard for calculating ground potential rise in most countries. Okay, new mission. That's not good. It's a heat wave coming. Now, heat waves result in people using extra air conditioners, which is a big problem where I am in Australia. Things get very hot. And people want to find ways to cool themselves down. Usually means not caring about your electrical network. So things will use extra electricity during this time. Now, the community notice, and this is sometimes what happens for me, is they might say, hey, the network's constrained. Can you maybe be a bit more energy efficient? Or if something goes catastrophically wrong, you can send a disruption notice. But you could consider doing that. I might actually do that. So that's a whole minute of reduced power usage. I think I'm just going to upgrade this. Actually, before I do that, so there's a lot of things that happen in the game that are quite complicated, and you don't really need to know, but it might be an option in the long term to, that's good, make progress, 25 million. It might be an option to expand some of these, but there's a lot of calculations that happen to actually determine these voltages to make it realistic, to essentially be a design for, with this substation under these conditions, with this soil resistivity, what sort of, is this a dangerous or safe environment? There's a lot of calculations occurring, and I've tried to display some of them under details here. So you can see for that substation that just overloaded, this is essentially a detailed calculation, what you would do in a design. You sort of work backwards, calculating based off what the earth installation is, what sort of voltages or what sort of current, earth fault currents you would expect. So I tried to essentially look at providing this, and it's something I'll expand on later. There's two different paths for the current here, and this path resistance is this, soil resistance, 50 hertz. US doesn't use 50, it uses 60, but all these things are actually can be changed within the game, which is quite interesting. Opens it up for future development. But yeah, I just thought I'd show you that there is sort of more in the background for these calculations and events that occur. Now, we have an event. Ooh, no power yet. Yeah, so we're in a heat wave. Things can go quite wrong. We have 1:50 left, and I've got 5 minutes left on this stream, so maybe that's good timing. We might be able to, let's speed things up. I really should have upgraded some of these so you can fail missions, of course. There is a penalty for it. It is dangerous, of course, having no power during a heat wave like we have at the moment. So I might I'll show you the best way to upgrade lots of things if you forget like I have, because I've been talking a lot. If you've got enough money, you can look at your entire network like the Power Study does do. It'll show you things that have failed. You can sort by the measured current in that particular area. Obviously, there's no current with something that's failed. And you can upgrade things. So, upgrade. We are increasing the rated current. It's now 22 millimeters square. And there we go. So that's looking quite good. There's a lot more to talk about in the game, obviously, and I wanted to also talk about another thing that isn't really done very well, probably not even very well understood by people, which is the electromagnetic field that's produced by these. Why am I on fast speed? That's risky. By these assets. So there is a mission which can come up. I think there's a few actually that asks you to deal with the electromagnetic fields within the game, which is why you have an electromagnetic field meter. And this allows you to measure the magnetic and the electric fields produced by your power lines or your substations or your other assets. And this is essentially what it does. So it does a calculation of your assets fields at that particular location based off a few different things. So if we're right next to the substation, and the substation is, in my game, the biggest biggest source of magnetic flux density or magnetic field strength, which is the main issue. So with my network, with the game, at the moment at least, it does 11,000 volts on the power lines. It's usually not an issue, but very high magnetic fields is an issue. So under the World Health Organization is a group called IEEE, the Non-Ionizing Committee for Radiation Protection, I think. And they set 200 microtesla for the exposure limits for the general public. And so this is something for you to manage as a utility. You can see here it goes red on the left. You can visualize essentially the ratio of where these sources are. So it looks a bit nicer in normal speed. But anyway, I haven't connected all my loads. I'm still in a heat wave. And so you have these really high magnetic fields here. You have some residential loads nearby. The industrial ones aren't as big an issue, but you might find, and I'll just move this here, you might find also that it's possible over time someone died of something else there, they get electromagnetic field sickness, and that can be an issue for you. So what you can do about that is to look at shielding. And this is an area of the game which needs a lot of extra, it's open for a lot of extra expansion of how you can modify your poles, capacitor banks, your conductors, that sort of thing, as well as look at shielding of your substations. So we'll go here. There's different sort of materials you can use. There's really expensive like composite materials. You can also just go on a budget and just put in some of these metal sheets. The Shield Be Right approach to engineering. I might just spend a little bit more. And you can see as we start doing this shielding that we can reduce the electromagnetic field of the neighboring community by a certain amount. So you see in bottom right here, 43% reduction of magnetic fields due to the permeability of these materials. And for this substation, you may not actually see it, but it builds it. It builds it and it collides with it, which may be a bit ugly, but it is physically here for all your substations. It's a bit nicer with the outdoor one here if you build it around the shell of the substation. But yeah, I just thought I'd show you that. That's pretty much the game at the moment. It is coming to early access very soon, so keep an eye out for it. You can save your progress in the forest. And it, of course, has many customizations I'm working on, customizations that are already in the game, different biomes. And that's really where I'll leave it. I hope you've enjoyed the stream. It's been a pleasure to be able to share this with you, and keep an eye out for any updates coming to the game. Thank you.